In Carl Sagan's cosmic calendar, our galaxy's death is only seconds away. If we compress 13.8 billion years of universe history into 1 year, the Andromeda collision happens just seconds from now. From a deep time perspective, it's very close. This perspective is the most powerful tool Carl Sagan developed for grasping time's true scale, the cosmic calendar. The entire history of the universe compressed from midnight January 1st to midnight December 31st. In this calendar, the Big Bang occurs on January 1st. In the universe's first seconds, temperatures exceed trillions of degrees. Matter and antimatter annihilating. Fundamental particles forming. Quarks combining into protons and neutrons. The first 3 minutes are crucial. Big Bang nucleosynthesis. Hydrogen and helium nuclei forming. The universe's basic composition determined. 75% hydrogen, 25% helium. All heavier elements don't exist yet. 380,000 years later, minus January 25th in cosmic time, comes the recombination epoch, electrons combining with nuclei, first atoms forming. The universe becomes transparent. Cosmic microwave background radiation escapes. 100 million years later, early February, first stars ignite. Population 3 stars, massive pure hydrogen and helium, short-lived but crucial. They begin heavy element production. As Carl Sagan said, "We are made of star stuff." These stars began creating star stuff. The first galaxies also form in February. Dark matter halos capturing gas clouds. Gravitational collapse. Star formation accelerating. The universe is no longer dark. First light sources illuminating the cosmos. Our Milky Way galaxy begins taking shape in late February. Initially small, irregular. Growth through mergers and accretion. Galactic cannibalism. Smaller galaxies being absorbed. Spiral structure gradually emerging. Our supermassive black hole Sagittarius Ace Right forms during this period. A 4 million solar mass monster. Accretion disk at the galactic center. Active galactic nucleus phase. Quasar-like activity feeding black hole growth. The galactic disk structure stabilizes in March. Spiral density waves creating arm patterns. Star formation concentrated in spiral arms. Gas compression triggering stellar birth. The galactic ecosystem establishing itself. Chemical evolution proceeds in parallel. Each stellar generation increases heavy element abundance. Oxygen, carbon, nitrogen, iron, life's building blocks accumulating. Metallicity gradients across the galactic disk. In May, the thick disk forms. Older, metal-poor stars, more spherical distribution. The galactic halo populated by globular clusters. Ancient stellar fossils preserving early galactic history. The thin disk emerges in June. Younger, metal-rich stars. Flatter, more organized structure. The sun's eventual birthplace. The solar neighborhood gradually taking shape. On August 31st, the 8th month of the cosmic calendar, the solar system forms. Solar nebula collapsing. Protoplanetary disk forming. Teotrari phase. Planetary accretion beginning. This is where our story truly begins. Solar system formation occurs at a critical time in galactic context. Enough heavy elements are available. Metallicity sufficient for rocky planet formation. The Goldilocks zone for liquid water. Life's prerequisites assembling. On September 2nd, life begins. Probably in hydrothermal vents. RNA world hypothesis. Self-replicating molecules. Information storage and transfer. Metabolism development. Life's chemical foundation. But for billions of years, months in cosmic time, only microbial life exists. Prokaryotes, dominating. Atmospheric composition gradually changing. The great oxygenation event. Photosynthesis altering planetary chemistry. Eukaryotic cells emerge much later. Complex cellular structure. Mitochondria and chloroplasts. Endosymbiotic relationships. Multicellularity becomes possible, but still in October, only simple organisms exist. In November, comes the Cambrian explosion. Complex life forms rapidly diversifying. Trilobites, early vertebrates, eyes evolving. Predator-prey relationships, ecological complexity increasing, but still primarily marine life. Plants colonize land in late November. Terrestrial ecosystems establishing. Oxygen levels fluctuating. Mass extinctions periodically resetting. But life remains persistent, adaptive, resilient. In December, dinosaurs reign. Mesozoic era dominance. Reptilian megafauna. Flowering plants evolving. Ecosystem complexity reaching new heights. But mammals remain small, nocturnal. The KT extinction occurs December 26th. Asteroid impact ending the dinosaur era. Ecological catastrophe opening mammalian opportunities. Adaptive radiation following. New niches being filled. Primates evolve December 30th. Arboreal adaptation. Enhanced vision, dexterity, social complexity beginning. Tool use emerging. But still far from human-level intelligence. And in the final hours of December 31st, literally minutes before midnight, Homo sapiens appears. Cognitive revolution. Language development. Art, music, symbolic thinking. Cultural transmission accelerating.
Agriculture develops 30 seconds before midnight. Civilization emerging. Cities, writing, mathematics, scientific method, technology acceleration, industrial revolution microseconds ago. The space age begins 4.1 seconds before midnight. We discover our galactic home, measure distances to stars, understand stellar evolution, realize our cosmic address. And now, at midnight, we're predicting the Andromeda collision, understanding galactic dynamics, contemplating cosmic futures. This perspective is Carl Sagan's greatest gift. Now turn your eyes to the night sky. Can you see the Andromeda galaxy? On a dark night, away from city lights, it appears as a faint patch of light. This is the most distant object visible to the naked eye.
Edwin Hubble proved in 1925 that Andromeda was a separate galaxy, using Cepheid variable stars for distance measurement. Before this, it was thought to be a spiral nebula. Hubble's discovery revolutionized the universe's scale. This means the Andromeda light you see now departed 2.5 million years ago. While Homo erectus was leaving Africa, while early hominids were crafting stone tools, Andromeda's photons were journeying through space. Each photon made a 2.5 million year journey through the intergalactic medium, avoiding dust clouds, maintaining coherence across vast distances, finally striking your retina, a message from the distant past, distant place. But Andromeda isn't just distant light, it's our destiny, because the Andromeda galaxy is coming toward us at 250 kilometers per second. That's 900,000 kilometers per hour, 21.6 million kilometers per day, 7.9 billion kilometers per year. Doppler shift measurements show this. Light from Andromeda is blue shifted. Wavelength is shortening, frequency increasing. This is definitive proof the source is approaching us. Spectroscopic evidence is undeniable. Actually, Andromeda also has transverse motion. Proper motion measurements show a sideways component, but radial velocity is dominant. Net result, collision course unavoidable. 4.5 billion years from now, seconds away in cosmic time, two galaxies will collide. But collision is a misleading term. Better to think of it as a galactic dance or cosmic merger. So what will this collision be like? A terrible explosion like in Hollywood movies? Stars crashing into each other? Planets shattering? Star Wars-style explosions? Actually, it's much more subtle. Galaxies are mostly empty space. Average distance between stars is millions of times larger than stellar diameter. Probability of direct stellar collision is extremely low. Think of it this way. If stars were ping-pong balls, the distance between them would be thousands of kilometers. Two swarms of ping-pong balls passing through each other. Very few actual collisions, but gravitational forces are enormous. The gravity fields of both galaxies will intermingle, tidal interactions dominating. Stars' orbital parameters will change dramatically. Some ejected, some captured, all redistributed. Computer simulations model this process in detail. The results are consistent. Tidal forces will distort galactic shapes, spiral arms disrupted, stellar streams forming, some stars flung to intergalactic space as hypervelocity stars. Simultaneous starburst activity occurs. Gas cloud collisions trigger compression. Star formation rate increases by a factor of 10 to 100. A short but intense period of stellar birth. Blue giant stars illuminating disrupted structures. The supermassive black holes will perform a gravitational dance at the center. Sagittarius A Pru has 4 million solar masses. Andromeda's central black hole has approximately 100 million solar masses. A binary system will form, initially in a wide orbit. Gradual decay through gravitational wave emission. Energy loss causing spiral inward. Eventually a final plunge and merger. A gravitational wave signal detectable across the observable universe. The final result, the Milkomeda galaxy. Milky Way plus Andromeda, Milkomeda. Astronomers John Dubinsky and T.J. Cox coined this term, a descriptive name for the merged system. Milkomeda characteristics, a giant elliptical galaxy, approximately 2 trillion stars, minus double the current combined total. No spiral structure, spheroidal/ellipsoidal shape, central bulge dominated. Red color will be dominant. Star formation rate declined post-merger. Blue giants are short-lived. Stellar population aging. A metal-rich evolved stellar mix. An entirely different night sky. So what will happen to our solar system? Computer models give very interesting predictions. Different research groups reach similar conclusions. The sun's fate is probabilistic, not deterministic. Scenario 1, 12% probability. The solar system will be ejected from the galaxy. Tidal kick during close passage. Orbital velocity exceeding escape velocity. Ejection to intergalactic space. Wandering stars among galaxy groups. This isn't necessarily catastrophic. Planets remain gravitationally bound to the sun. Solar system integrity maintained. Just isolated from galactic environment. No stellar neighbors. Dark sky except for distant galaxy light.
Scenario 2, 71% probability. The solar system will relocate to Milkomeda's outer regions. New orbital radius 2 to 3 times current distance. Galactic suburbs rather than current neighborhood. Still part of the galaxy but relocated. Scenario 3, 17% probability. The solar system will migrate to inner regions. Closer to galactic center. Higher stellar density. More frequent close encounters. Potentially more dramatic but not necessarily catastrophic changes. In all cases, planetary orbital stability remains fundamentally unaffected. Earth-Moon system, Mars orbital parameters, giant planet configurations, all preserved. The Sun's gravitational dominance overwhelms galactic perturbations, but what will the Sun be like by then? 4.5 billion years hence, solar evolution will have progressed significantly. Currently 4.6 billion years old, middle age for a G-type star. Stellar evolution is predictable. Hydrogen fusion in the core gradually changes composition. Helium accumulation causes core contraction. Outer layers expanding, luminosity steadily increasing. In 1 billion years, solar luminosity will increase by 10%. Earth's average temperature rising correspondingly. Ice caps melting, sea level rising, climate zones shifting poleward. Habitability challenged but not eliminated. Conservative estimates, 1 billion years until Earth becomes too hot for complex life. Liberal estimates, 3 to 4 billion years. But certainly before the Andromeda collision, Earth will be uninhabitable by current life forms. 3.5 billion years from now, solar brightness will be 40% above current levels. Earth's surface temperature exceeding 100 Celsius. Oceans completely evaporated. Thick steam atmosphere. Extreme greenhouse effect. Life impossible on the surface.
5 billion years from now, helium flash will initiate the red giant phase. Solar radius expanding 100-fold. Mercury and Venus orbits engulfed. Earth's survival questionable. Atmospheric stripping by solar wind. Tidal heating effects. So by Andromeda collision time, the Sun will already be a white dwarf. Earth either destroyed or a frozen airless rock. Life long extinct on Earth, or migrated elsewhere. But this pessimistic scenario assumes no technological intervention, an alternative possibility. Life adapts, evolves, develops stellar engineering capabilities. Homo sapiens ancestors become post-biological intelligences. 5 billion years is an enormous time span for evolution. Consider, 3.8 billion years ago, only simple bacteria existed. 550 million years ago, the Cambrian explosion. 200,000 years ago, anatomically modern humans. 10,000 years ago, agriculture. 200 years ago, industrial revolution. 50 years ago, the space age. An exponential acceleration pattern. Technological capabilities doubling every few decades currently. Extrapolating 5 billion years. Impossible to predict specific capabilities. The Kardashev scale framework is helpful. Type 1 civilization harnesses planetary energy output, minus approximately 10^16 watts. Type 2 harnesses stellar output, minus 10^6 watts. Type 2 harnesses stellar output, minus 10^6 watts. Type 2 harnesses stellar output, minus 10^6 watts. Type 1 zespeving to 6 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 watts. Type 3 harnesses galactic output, minus 10^6 watts. We're currently type 0.7 approximately. Reaching type 1 within centuries is likely. Type 2 within millennia or tens of millennia. By Andromeda collision time, type 3 capability is a realistic possibility. Type 2 capabilities include stellar engineering, Dyson spheres or similar megastructures, solar wind control, stellar mass loss manipulation, main sequence lifetime extension, red giant phase prevention or control. Maybe descendants will modify solar evolution, prevent habitable zone migration, maintain Earth-like conditions indefinitely, or migrate to the outer solar system, Jupiter's moons, Saturn's system, Europa, Enceladus's subsurface oceans, Titan's hydrocarbon seas. These worlds might become habitable as the sun brightens. What's currently too cold becomes temperate. Solar system habitability expanding outward, or maybe completely different evolutionary paths, uploaded consciousness to digital substrates, quantum computers, biological bodies optional, physical space travel irrelevant, information transmission at light speed. Carl Sagan was prescient in pale blue dot. The surface of the Earth is the shore of the cosmic ocean. Some part of our being knows this is where we came from. We long to return. And he continued, to me it underscores our responsibility to deal more kindly with one another, and to preserve and cherish the pale blue dot, the only home we've ever known. But ultimately, the cosmos is within us. We are made of star stuff. We are a way for the cosmos to know itself. The Andromeda Colisi.